This video is on section 1-3 on measuring segments. By the end of this video, you should be able to identify the coordinate of a point on a number line, identify the length of a segment on a number line. You should be able to use something called the segment addition postulate to find segment lengths or to solve for a variable, and also to define and identify midpoints and segment bisectors. Let's get started. We're starting off with a postulate, which again is an accepted statement of fact, and that is the ruler postulate. Okay, and the ruler postulate is that every point on a line can be paired with a real number. Okay, and this makes a one-to-one correspondence between the points on the line and the real number. So there's a way of pairing every point on a number line, every point on a line with a real number. Okay, so that every distinct point has a distinct number. Okay, and what number it's paired with is called the coordinate of that point. Okay, so in simpler terms, every point on a line has a coordinate, some real number that corresponds with that number. Okay, now looking at the picture, I think it'll make sense that the coordinate of S is -4. That's the number that corresponds with point S. The coordinate for point T is 8, the number that corresponds with that point. The coordinate of V is 14. Okay, so the ruler postulate just gives us a reason of why we can assign points on number lines numbers. And that'll be useful to us as we begin to talk about distance and about lengths of segments on number lines. Okay, the way we've refined the distance between 2 points is by taking the absolute value of the difference in their coordinates. Okay, remember that these two lines, not parentheses, the lines are absolute value, and what that means is that whatever is in here, we make it positive. Okay, that's not the definition of absolute value, but kind of that's a working definition. You can use that, and it works out just fine. Okay, so what is the distance of ST, or the distance between points S and T? Let me show you first on the picture. I think that'll make a little more sense. And then we'll use this formula with absolute value, and you can use either one that you want. Okay, the distance now from here to here is 2, 4, 6, 8, 10, 12. Okay, so the distance between S and T is 12. Now, let's use our absolute value formula. It's the absolute value of -4 minus 8. Those are the two coordinates. I'm sorry, not parentheses, it's the absolute value. All right. So -4 minus 8 is -12. Okay, now the absolute value, if you make that positive, you get a positive 12. The same exact thing we got before. Okay. Also, let me point out the fact that it doesn't matter which order you put it in. If you prefer to do 8 minus a -4, which minusing a negative is the same as adding, and you get 12, absolute value of 12, which is still 12. Okay, if you prefer to use the picture or prefer to use the formula, either way it's fine, but you should be able to find the distance between 2 points and the length of a segment. Okay, let's just try one more, make sure you got it. Let's find the length of TV. Okay, I'll do the picture. 2, 4, 6. Or if you use the absolute value, we could do, I'll just do 14 minus 8, and I get the absolute value of 6, which is 6. Okay. Now, here's a really important point that something I've been using, but I haven't really talked about it exactly, is that ST with a line on the top is a segment. That's segment ST. If it doesn't have that line on the top, ST is a length. So without the bar on top, it's the length of segment ST. there's a difference between a length that's a number and a segment that's part of a line. Okay, please don't get these confused. Okay, that kind of leads us into the segment addition postulate. Again, a postulate is an accepted statement of fact. And if 3 points, A, B, and C, are collinear, meaning on the same line, and B is between A and B, then then the length AB, this length, plus length BC is equal to the length of AC. Okay, so if I add up all the parts, it's equal to the whole. Okay, which I hope makes sense. And let's use it a couple of times to make sure we really got it. So if the length of AB is 2, and the length of AC is 7, then what must be the length of BC? Well, I think by seeing it, it's going to be 7 minus 2, which is 5, or because 2 plus 5 is 7, that must be the length of BC. Okay? That if you add up the two parts, it's equal to the whole. Okay? What is the value of x? Now I'll be kind of creating an equation and then solving it. So the sum this part plus this part is equal to the whole. That's what the segment addition postulate tells us. And so x plus 3, okay, this part plus this part, is equal to the whole. Okay, so I'm going to combine like terms. X plus x is 2x plus 3 is equal to 11. Now the way I'll solve this equation is by first getting rid of this plus and minus number. That's usually the easier way to do it. And I'll do it by doing the opposite of adding 3, which is subtracting 3. And 2x is equal to 8. And the way I get rid of a multiply by 2 is by dividing by 2. And x must be equal to 4. And if I just plug that in just to check, 4 plus 3 is 7. 4 plus 7 is equal to 11. So that must be the correct answer. Okay? So the sum of the parts is equal to the whole. If DE is equal to 4x plus 6, and EF is equal to 7x plus 15, and DF is 120, what is the value of x? Now, there's no picture for us. I'll just draw one real quick. Let's see here. D. This must be E, and this must be F. Now, this is not to scale, because I don't know what the lengths are. But let's see here. DE plus EF must be equal to DF. So 4x plus 6 plus 7x plus 15 should be equal to 120, because this part plus this part is equal to the whole. Now, I will solve this equation by first combining the like terms. 4x and 7x makes 11x's, and 6 plus 15 is 21, and that's equal to 120. Okay, now I will solve this by first doing the opposite of adding 21, which is subtracting 21. And this cancels. I get 11x is equal to 99. And I divide both sides by 11, because that's the opposite of multiplying by 11. And x is equal to 9. Okay, before I leave this question, I'm going to check my answer. Let's see here. 4 times 9 is 36, plus 6 is 42. And 7 times 9 is 63, plus 15 is 78. And 42 plus 78 is equal to 120. Okay, so the answer must be 9. Okay, so that's, okay, one more application of the segment addition postulate. Now, it doesn't look like the same picture, but it's still the same idea. Okay, first to find this length, this is 2, and 2 and whatever that length is must make up 7. So this must be 5, because 2 and 5 make 7. And to find this length, it must be equal to the sum of the parts. 2 and 4 together make 6. Okay, again, we're using the segment addition postulate, and it'll show up kind of sporadically throughout the year, this idea of the segment addition postulate. It's pretty useful. Okay, a slightly different idea is the idea of congruence. Now, when two segments have the same length, they're said to be congruent. Okay, now we don't say that they're equal to each other, because to be mathematically equal, everything must be the exact same. Okay, so two different segments that have the same length, the word we use is congruent. Okay, and that same word congruent is what we use for angles. We use that for triangles. We'll use that for squares and rectangles that have the same shape. We'll use the word congruent, and we'll save the word equal for things that are the exact same, which usually are just numbers. But if two things are the exact same, we'll call them equal. Okay, midpoints. Okay, in this picture, what these little dashes mean is that this segment is the same as this segment. Okay, these segments are congruent. That's what the dashes mean. Now, since R is in the exact middle of the segment, we call it the mid segment. Okay, I'm sorry. It's called the midpoint because it's the point in the very middle of the segment, so it's the midpoint. Okay, a related idea that's a lot less common is the idea of a segment bisector. Okay, so this green line right here, RT, it intersects segment QS at the midpoint, because R is the midpoint, it's in the very middle. We say that this line bisects the segment. Now, what does bisect mean? It's of two words, two parts, sorry. Bi is two, like a bicycle has two wheels, and sect means to cut, or sections. And to bisect, it means to cut in two, or to cut it in two equal pieces. And so this line bisects the segment. It cuts it into two equal pieces. Okay? We also call line RT a segment bisector. Okay? All right. I think we have time for one challenge question. Let me just set this up. We're kind of getting low on time. But if U is the midpoint of TV, of segment TV, what is the length of TU, UV, and TV? Okay, I think we'll have time just to set this up, and then if you want to solve it, you can, but I think there's something like this on the homework. Okay, so if U is in the very middle, it must be that this part is congruent to this part. Now we use dashes to say that. Okay, in other words, that 8x plus 11 must be equal to 12x minus 1. Okay, now we can take the time and solve this equation by subtracting 8x from both sides. I'm going to go a little fast. Okay, and then I'll get rid of the minus 1 by adding 1 to both sides. And then I will get rid of the multiply by 4 by dividing by 4. And x is equal to 3. Okay, now the answer to my question is not 3. I'll need to go back and plug things in to find the actual lengths, but at least that shows you how to set up the problem. This video was about measuring segments, about coordinates, finding lengths of segments on number lines, also what the segment addition postulate is and how to use it, and also we talked about midpoints and segment bisectors.